Happy morning, students. So today we are going to learn about the error analysis. I hope you have understood clearly about the error and its type. Right? So error is a very important topic in our physics, and it is a very important question for your state board examinations also. Right? So you have to clearly know about it. And today we are going to discuss about the error analysis, how to eradicate the error in the calculations and what types of equations we have to use it. Then in our next video, we learn about the propagations of error which takes place in addition, subtraction, product, division and the power of a quantities. So today we are going to learn only about the error analysis and its equations, and we are going to revise again the errors because it is a very important concept and the terms and conditions and the definitions should be remembered in your mind. So we are going to again revise the error and we are going to learn about what error analysis in today's class. Right? Let us start.
Now, we are going to study about error analysis. So, we have studied detailedly about what is an error and its type. Now, we are going to study about if any measured value is taken, means how to eradicate the error. We call that as what error analysis. So, we are going to use how to value the error. The first one is absolute error. What do you mean by absolute error? Absolute error is nothing but it is a difference between the true value and the measured value of a quantity. Right? We already studied. So true value, how to get a true value? We are taking about 2 to 3 readings means then the true value will be what? Yes, it is a arithmetic mean of all the measured value. So how to express arithmetic mean? We studied it. It is in random form. Right? AM is equal to, that is what arithmetic mean value will be equal to summation of all the measured value divided by the number of values. Right? So it will be represented in terms of what? So 1 by n summation of I is equal to 1 to n ai. So this value will give rise to what? A true value. So we arrive at a true value from our measured value. Then how to obtain measured value or absolute error? So absolute error is nothing but it will be represented by delta. So delta A1, how to represent it? It is delta. So del A1 is equal to what we said, true value and a measured value. What is a true value? So mean arithmetic value is a true value. So true value minus the first measured value which is A1. So arithmetic or absolute error del A1 for the first one will be equal to what? It is a true value, that is arithmetic mean value minus the first value. Similarly, the next one, next absolute error will be equal to what? The true value, arithmetic mean value minus A2. So we can go on repeating for all the 10 values or the 5 values what we have taken. So we have written as del AN will be equal to AM minus AN. So that is the thing to calculate what? The absolute error. If we take an example, so we are traveling in a by-current car. So we are moving at a speed of, we are saying that it is 60 km per hour. Right? But actually, I am moving in a term of what? A 62 km per hour. So I am moving in the speed of what? It is a 62 km per hour. But it is recording, it's showing me what? It's showing 60 km. So I am saying this is a true value. Which is a true value? 62 km per hour only I am moving. But the instrument speedometer is showing me what? It is 60. So we call this as a measured value. We call this as what? Measured value. Then how to find an absolute error? Then absolute error can be found to be equal to what? Del of any value will be equal to del of A will be equal to true value minus measured value. So what is true value? It is 62 minus 60. Then it becomes to be 2. 2 km per hour will be what? The absolute error. Right? So we can call it as what? So true value minus measured value. This is true value. We call this 2 as what? Absolute error for this measured value. Can you able to understand that? Right. The next will for mean absolute error. What is it the mean means? Take an average. Average is said to be what? A mean absolute error. So what I am going to take here, we are not going for error. We are going for a mean absolute error. So it is an arithmetic mean of a magnitude of an absolute But here we will take a magnitude value. Why I am taking a magnitude value? Because if I say this true value is 62, but the measured value is 64 means I will get the answer to be equal to what? -2. Right? So I will get the absolute error in terms of both in terms of positive one and both in terms of negative one. Right? I will get both positive value as well as negative value. So in order to eradicate the negative and positive value, we are taking a magnitude. If anything has been taken as a magnitude means we should not take the negative sign into account. We have to take only the value into account. We should not take whether it is a positive or it is a negative. So I am going to take a magnitude of all the absolute values. So absolute value will be represented by what? It is the del A. So it is addition of all the absolute value divided by the number of absolute value. Right? We can call that as what? Is a mean value. If it is a true value means we will write it as AM. It is a mean absolute value means we will represent the symbol called what? Del AM. Therefore I can write in a short form del AM will be equal to 1 by n summation of I is equal to 1 to n. It is a magnitude of del AI. Am I right? Right? So you have to clearly understood that difference between AM and del AM. AM stands for a true value and del AM stands for a mean absolute error. Right? Here if it is a A comes, then M comes, then we can say it is what? It is a mean value. Right? Simply we are writing only del A. If you are writing del A means that will stands for what? Absolute error. If I am saying it is a del AM stands for means it is a mean absolute error. If it is simply AM means what? It is a mean arithmetic true value. It is a true value. Right? Then the magnitude of this value will lies from AM plus del AM and AM minus del AM. So that is the meaning for this value. Can you able to get it? So we have studied about what? First one is absolute error. Absolute error is nothing but what? It is a true value minus measured value. Then we went for what? Mean absolute error. What is the mean absolute error means? Adding of all the absolute errors divided by its number. Then we can say that is as what? A mean absolute error. Right? Then now we will go for a relative error. What do you mean by relative error? What does the word relative stands for? Relative error is nothing but it relates to things, right? What it relates? It relates between a mean absolute error and a mean value. The mean absolute error and a mean value. We have calculated the mean absolute error, right? So and a mean value is what? A true value. So relative error is nothing but it is a ratio of a mean absolute error and a mean value. So it will be represented as what? Del AM. Del AM stands for what? It is M stands for mean value. Mean value of absolute error. Del A stands for what? Absolute error. Del AM divided by AM. AM stands for what? True value. So we call this as what? Relative error. And the last one is a percentage error. What is that percentage error? We are going to represent the relative error in terms of a percentage. Then that type of error is said to be what? A percentage error. So we say that what is the relative error formula? It is del AM by AM into 100. That represents what? It is a percentage error. So these are the terms and the formulas which has to be used in what? Error analysis. The first one is arithmetic mean. What is arithmetic mean will be? It is summation of everything divided by the number of terms used. Right? So we represent it symbol by what? AM. Small a. M stands for what? A mean value. A is a number, any number, right? So AM stands for what? It's a mean arithmetic value. When say that it is a true value. Then what we are saying, it is an absolute error. What is absolute error? Absolute error will be represented in terms of what? Del A. Right? So we represent in terms of what? Del A. So how to calculate del A? Del A is nothing but a true value minus measured value. So for each measured value, we have to find an absolute value. Right? We have to find what? Absolute error for each measured value. So we have to represent as del A1, del A2, del A3. Like that we have to go for that. Then we have to take for what? A mean absolute error. What do you mean by mean absolute error? All the measured absolute errors divided by the number. Then we call that as what? A mean absolute error. It will be represented by a symbol called what? in an experiment, the reading of a period of oscillation of a simple pendulum. So, for a simple pendulum, they are recording oscillations, which has been found to be repeated oscillations, 20 oscillations. You will do this as a practical, right? So, simple pendulum with the time period calculation, we will do as a practical. So, simple pendulum, they are calculating it and finding a measurement value for each one is 2.63 second, 2.56 second, 2.42 second, 2.71 second and 2.80 second. Right? They have taken 5 sets of reading. 1, 2, 3, 4, 5. 5 readings they have been taken. And they are asking us to calculate the mean value for it, then absolute error, a mean absolute error, relative error and a percentage error for this time period calculations. We will start it first. To find a mean value, so first we have to write a given data. So we have 5 sets of time period. So we have represents all the 5 sets. So everything has been given in terms of what? Second. So it is a given fundamental unit. Therefore it is right. Then we will go for the first one, mean value. How to calculate the mean value? It is the average of all the readings. How many readings has been given? 5 readings has been given. So it is a T1 plus T2 plus T3 plus T4 plus T5 divided by 5. So this is the method to calculate what? A mean arithmetic value. So that is nothing but what? It is a true value. So T1 we know, T2, T3, T4, T5. So we have substituted all these values and we are dividing it by 5. Right? Then if I add all this value, it gives rise to what? 13.12 divided by 5 gives you 2.624 seconds. If I want to round off to a 2 decimal point, so I can say that the 4 is which is less than 5, therefore it is 2.62 seconds. So I have found the true value of a time period to be equal to what? 2.62 seconds. So we have found the mean value. Now we are going to find about what? The absolute value. So absolute value can be written as a formula. Absolute value, how we will write? We will write as del m or del t. Or del t will be equal to true value minus individual time value. Right? So del t stands for absolute error. Tn stands for a mean absolute value or mean, not mean absolute value. It is a mean value minus the individual time period. So that is the formula for calculating what is a mean absolute value or an absolute value. Right? So absolute value del T1 will be equal to, what is the true value we measured here? 2.62. So 2.62 minus the first time period. What is the first time period which is given? It is 2.63. It is 2.62 minus 2.63. The answer is what? Minus 0.01 second. Similarly, we have to find it for what? The 5 readings. Del T2 is equal to 2.62 minus 2.56. So if I subtract, I will get what? Plus 0.06. So here again, plus 0.20. Again it is minus 0.09. Again it is what? Minus 0.18. So we have calculated what? We have calculated an absolute error. Right? So these represents what? Absolute errors of 5. Now we have to take a mean absolute error. So mean absolute error will be taken in terms of magnitude. Why we are taking magnitude? In order to eradicate this negative and positive sign. Only we have to take the value. We should not consider the negative and positive sign. That's why we are representing the value in terms of what? A magnitude. So a mean value means what? Adding all these 5 terms with number 5. So that will gives you a mean absolute error. So it will be given by the symbol what? Del Tm. Right? So it is a magnitude value. So we are taking only the magnitude value, right? It is a magnitude value. Magnitude value is what? We are given only the values. We add all the values and we divide it by 5. So it is 0.54 divided by 5. It gives you 0.108 second. Therefore, in order to put it in a 2 decimal point, it is greater than 1. Therefore, it takes one more value. So we are saying it as 0.11 second. Right? So we have calculated mean value and we have calculated absolute error and we have calculated the mean absolute error. So 3 things we fetch. Then we are going for what? A relative error. What do you mean by relative error? The formula which relates a mean absolute 0.62. Right? Therefore, the value is equal to what? 0.04. Here I didn't put a unit. Why I didn't put a unit? So this is second and this value is also second. Both gets cancelled. So it has no unit. Right? Relative error will have what? No unit. So it is only what? It is 0.04. Then I want to represent this value in terms of percentage error. So percentage error means what? Del Tm by Tm into 100. Therefore 0.04 into 100. So it turns for 4%. Right? Therefore I can say that the true value of a time period of a simple oscillations can be given by the reading. What is the true value? It is 2.62. So therefore I can write an equation, a time period t will be given to be equal to 2.62 is a true value, that is plus or minus 4%. The error can be what? It can be, we found the percentage error to be equal to what? A 4%. Therefore the time period of oscillations can be written to be equal to the mean value, that is a true mean value of a time, 2.62 plus or minus 4%. Is it clear to you? So I will also give you one other example since you have to do it. Right? Then.
Now we are going to revise our area. Right? It is a very important topic which is some students will find difficult in understanding. So I am revising it again. Right? So if you know thoroughly about error, we can go for a propagation of error. That is also a very important topic. Right? So error analysis. So we studied about error analysis and we learned about the formulas to eradicate the error. Okay, we will recall once again all the things which is in it, right? So what is an error? So error is said to be what? Uncertainty in any value, measured value means we call that as an error, right? Some unexpected values, we call that as an error. So error can be said as what? How to calculate? It is nothing but it is a true value minus measured value. What is a true value? Minus measured value. And we say that error has been divided into two types. One is called as systematic error, another one is called as what? Random error. What do you learn about systematic error? Yes, it is what? It is a reproducible accuracy in any one direction. So the error will repeat once again in a same standard manner. We call that as a systematic error. We are not able to eradicate the systematic error. We are not able to minimize the eradicate error. If I am choosing any instrument, my tape or a measuring tape also, if that tape is very loose or it is very flexible means, so there will be some minute error in measuring that any object using that tape. We call that as a systematic error. So we have to say that this is not proper measuring device. So we have to use a proper device means then we have to go on. So by using it repeatedly for a long period of time, automatically there will be some minute error will take place. So everything will becomes to be what? Some not perfect in it. So I'm going on weighing it in the machine, right? So there will be some accuracy, some amount of value will be what? Error will be formed. But it is not due to what? Our mistake, right? It is the instrumental mistakes due to which what? It has been used for a prolonged period. So it has some error in it. We call that types of error as what? We call that as a systematic error. Right? If I take a screw gauge or Vernier caliper, by using a screw gauge continuously, there will be some that screw will be, or rotating screw will be somewhat loose. So automatically, initially while buying it shows me zero error. By using it for a long period of time, automatically it will show some error in it. So we have to think over it and we have to see it and we have to present it and we have to counter error to find it. We call that as what? A systematic error. So systematic error can be divided into many things. One is called as instrumental error, imperfection in experimental technique, personal error, errors due to external causes, and least known error. So instrumental error means what? So during the production or during the thing, the calibration of a scale or something will be what? Missed over or wrongly calculated. So that type of thing is said to be what? Instrumental error. So this can be minimized by choosing a proper instruments for measuring it. We call that as what? Instrumental error. The next is what? Imperfection in experimental techniques. So by setting in any experiments, we have to keep very clear about the surrounding temperature, we have to study about the thing, everything we have to do it. So we have to, what are the steps to be done before doing that experiments, we have to be very keen about it. By putting an AC and doing a heat experiment is not a good, right? So because the surrounding temperature is very high and we are doing heat experiment and expecting a perfect value means we will not do it. So for doing any heat experiments, we have to keep our thing to be what? Insulated, because the surrounding temperature should not affect my heating body or anything. So we call that type of thing to be what? Imperfection in the experimental technique, right? The next is personal error. So our error. So by measuring an instrument also, we are calibrated anything, mistakenly taking any reading. So we have to do a temperature readings also, we'll use what? A wrong calculations. Instead of setting a time by 5 degree, one time I'm giving for 5 degree, another time I'm giving for 6 degree. So randomly I'm doing it if that time is set to be what? So it's a personal error. It's purely due to our mistakes, right? Then error due to external causes. So you know that error due to external causes means what? Due to pressure, temperature, volume, voltage. So due to that some error is taking place. Means we call that type of error as what? Is a error due to external causes. The last one is least count error. So least count is the one which is called as what? The least measurement that can be taken using an instrument. We call that as a least count error. So for measuring any small dimension also, we have to choose a proper instruments for measuring the smaller dimensions. Right? So I should not go on taking for measuring a small thickness of a wire, I should not take a measuring tape or a scale. So thickness of wire can be measured using what? A screw gauge only. So for that I have to choose screw gauge. So instead of that, if I take a twine and I hold it and I measure it using a scale, so it is not a perfect value. Though I will get a measurement, but it is not a very perfect value. So the least count, which instrument has to prefer for measuring what? So that has to be taken for that. Is it clear to you? So we call that as a systematic error. A systematic error means which will be continuous. It's a constant value, but it will be continuously repeating in all the measurement and everything. We call that as a systematic error. And the systematic error cannot be easily eradicated. So we have to very carefully minimizing that systematic error. The next is what? A random error. Random error means what? We didn't expect anything randomly happening. So voltage fluctuation. Our home, there will be voltage fluctuation will be there. It is not constantly will be 220. Sometimes it will be 218, sometimes it will be 220, sometimes it becomes to be 217. Randomly it is all changing this manner. We call that as a standard error. We can also call this as chance error, the chance in which happens. So it can be minimized. It can be minimized using what? By taking an arithmetic mean. By taking all the measured values, summing it off and taking a mean value, we can be easily able to minimize or eradicate the random error. Am I right? So the formula for arithmetic is what? AM is equal to, is the summation of I equal to 1 to n AI by n, and gross error is nothing but, so the gross error comes in the systematic as well as what? Random error. It is a personal error. So we can say that it is nothing but it's a sheer carelessness of an observer. So our mistakes by without taking a proper ideas or without having any proper setting for an instrument or calculation in a wrong manner, putting a standard values in a wrong manner, and anything we can call that as what? A gross error. So we call that as a personal error. Personal error can be of both random as well as a systematic error. Is it clear to you? So error is a very important concept, and that's why I have again revised you this. This is one of the very important 5 mark questions for your state board examination. So repeatedly in this video also you go for the assignments I have given the same. So you thoroughly learn about the error and its error analysis and all the formulas. So now we will watch again the videos of what? So visualize the video about accuracy, precision, error and error analysis, and for your best understanding. So we will do it. Thank you.
Let us have a visualized idea about accuracy, precision and the error analysis. So listen now. So we already studied that the precision or accuracy. Accuracy is how far the value is very nearer to the true value. So here 1, 2 and 3 is there. So the 5 arrows has been given in the arrow 1. So we can say it is more accurate. Now it has been randomly scattered. We can say that it is not accurate and not precise. If I repeat it again, so all these 5 arrows has been given at some other different point, that is in the point 3. So it is not accurate. If I do it at the 1, it is very accurate. If I doing it repeatedly at 3, it is not accurate, but I am very precise. Therefore, I can say that, so this is not less accurate and more precise. Now let us measure an length of an object. So its original length is 32.56 millimeter. Now I am going to use 2 different measuring scales to measure its length. The first scale has a least count of 0.1 millimeter. So if I measure it with that, it shows me the length equal to 32 millimeter. If I measure the same thing with the help of another measuring scale, so we can say that it is 0.1 or 2 millimeter. So we can say that it gives a value of 32.5 millimeter. So I can say that the first one is not accurate to the true value and but is less accurate, and the second one is more accurate to the true value. I hope you have understood the accuracy level. If I say about the precise value, the 32.5 is more accurate and also more precise. The 32 value is less accurate and less precise. If I use a vernier caliper to measure this length, means it shows me 32.56. Therefore, this measurement is very accurate and also very precise, because we know that the least count of this vernier caliper is what? 0.01 centimeter. Now we'll go for error. So we have studied that there are 2 types of error. One is a systematic error, another one is a random error. And systematic error has been divided into many things, that like instrumental error, personal error, imperfection in the arrangement of an experiment, and so on. So we are going to see one by one. Imperfect instrument, faulty technique, and incorrect process. So everything will come under what? Systematic error. So if I take an example of a perfect balance between left and right, we have to see that. So if you see the arrow mark in the first diagram, it has been given upwards. That means the left balance and the right balance are equally balanced. If I see it in the imperfect balance, the right arrow has been shifted towards the right side. Therefore, the balance will be, it's not a proper division. So while doing measurement in this, we have to set for a proper notation. If we take the temperature measurement of a baby, the doctor is measuring at the ankle, right? So measuring at this point will have some effect, right? It affects by humidity. The mercury of the thermometer will be affected by the humidity, air and atmospheric pressure. It does not accurately measure the temperature of the child. When I do it in the mouth, it will shows me accurate measurements. Right? So if I say the scale, so I'm taking a measurement, means the position and the tilt of a head should be proper. If I view it from a left or right side, my head has been tilted, so the measured value will be very long and it will show me error of 0.1 millimeter or so. Therefore, I have to measure it at the straight angle and my eye position should be on the scale. Right? So left side and right side measurements are wrong. So only the position should be what? It is straight to the right, that is we have to upper it. So this correction of the systematic error can be done by us only. So by doing physical balance, we have to check the positions and we have to measure the temperature in the mouth and we have to place in a right position to see the measurement. Now we'll go for a random error. So random means what? So it is randomly occurring, means it is not in a perfect manner. So it is not regularly happening. It is not systematically happening. So that types of things are said to be in what? Random errors. I hope you have understood clearly about systematic and random errors. In random errors, we can say that it is unpredictable situations like voltage fluctuations, mechanical vibrations. So depending upon voltage fluctuations and the mechanical vibrations, everything will be affected. So we will not say that randomly, this is randomly happening. So one time we'll have a high fluctuation, one time has a moderate fluctuation, one is a very least value. So there is no perfectness in the value. We call this type of thing as what? A random error. Now the last one is a least count error. We know that there are 4 different instruments has been shown here. So least count of 1 centimeter, next one is least count of 0.5 centimeter, next is 0.2 centimeter and the least count of 1 millimeter. So what is the least count? The least value that can be measured using an instrument. So if I use a different instruments for measuring different things, it will give rise to what? Some errors in it. So I have to choose a correct values in instrument to measure a correct values. Now the least count 1 millimeter. Now we can see that already we have seen about vernier caliper and a screw gauge. So in vernier caliper we know that the least count is 0.01 centimeter and we can say that in screw gauge the least count is what? 0.01 millimeter. So vernier caliper least count is what? 0.01 centimeter. It is screw gauge in terms of centimeter we can say it is 0.001 centimeter. So this is a digital vernier caliper. We can easily able to move and see the value, right? Now, another way to reduce the least count error is to repeat the measurements and take the arithmetic mean to find the measured value closer to the actual one. We know that the systematic error cannot be neglected, so it can be rectified only by our sensations, but random errors can be neglected by taking a arithmetic mean. What has been the arithmetic mean? It is a summation of all the measured value by the whole numbers. How many terms we have repeated the experiment, it gives me the arithmetic mean. The formula for it is what? Summation of I equal to 1 to n divided by n. That is the formula for taking a mean value of the measured values. Now we'll go for an absolute error. What is that absolute error? The true value minus measured value. So each measured value will have some absolute errors and the absolute errors will be represented by del A. So we are here taking modulus of del A. Why we are taking modulus of del A? Because minusing of true value to measured value will give both positive value as well as a negative value. But absolute error will tell only the magnitude. So we have to neglect the positive and negative sign. So we are taking a modulus value. So we have a common formula. Del AN is equal to what? AN minus A mean. So A mean is the measured value. AN is the true value. I hope you have understood it. So del A is always what? Positive. That is because it is magnitude value. Right, we can write it in the shortest notation as what? Summation of I is equal to 1 to n modulus of del AI divided by n. That is, it lies between, the value lies between A mean minus del A mean, that is less or greater than equal to A, or A mean plus or minus del A mean. So it lies between positive value and a negative value. So A is a real one. So the value is what? A mean minus del A mean or A mean plus del A mean. The value lies between the negative one and a positive one. So we'll say is that del A. Del A stands for what? Delta A mean by A mean. So absolute error mean divided by what? The real arithmetic mean. If I want to calculate the percentage error, we can say that it's a relative error into percentage. That is delta A mean by A mean into what? 100%. Thank you.